Hey everybody, today I'm going to show you how to compare meshes in Meshlab. I see most people use something like GeoMagick, which is expensive or you just might not have access to, but Meshlab has a lot of cool quantitative tools for comparing meshes and visual tools as well. So I'm going to show you how to do that. So the first thing you need is to download Meshlab, and there's a couple of functions in the latest stable 2022.02, which a couple of features that I like to use that aren't working. So I'm using a portable version of Meshlab where those functions are working. And I think this is it here that I downloaded. My file folder says 2022.02 Windows, but then whenever I open it up, it's 2023.05. So try that out, and most everything that I'm going to show you works in the latest stable anyways, if that's what you have. So I'll point out which features are the ones that are not working. So first thing I'm going to do is get my folder here. I've got a couple of skull models that were generated from CT scans in the Mimic software, which is not free. This is just a nice example that I have, and it's using two different reconstruction algorithms to go from the 2D CT segmentation to the 3D model. And I'll show you some ways to compare these. So I'm just going to drag and drop them in here. First thing you'll notice is that we're not in orthographic view. So if you just hold shift and then scroll down, you'll get there, and you can see FOV down here at the bottom says ortho, and you can see the layer dialog here. That's where you toggle visibility for your different models and where you select a model before performing an operation. And you see that these came into the same location because they're from the same CT scan. So that makes this type of comparison a lot easier. Another thing you'll notice is that they don't look super different unless we change from vertex shading to face shading. So right now they're set to vertex shading. So if you click on the little solid cylinder here and switch to face shading, then suddenly you see the optimal reconstruction skull. You can see the triangles really well. You can see all these flattened surfaces. And same with the gray value if we switch it to face shading, and you can see the triangles a little bit more, but it still looks pretty good and looks a lot better. So one thing you can do to first do a visual comparison of these, because they're in the same location, we can go up here to Windows and we can say split current view, and I'm going to choose vertically. Now the window that is active has a purple bar down here, this brighter purple. So let's make one of the skulls invisible in that window. You notice it's gone back to the field of view has changed. It's not in orthographic anymore. So let's hold shift and then scroll. We can also get rid of the little circle thing. Under view, show trackball, get rid of that, okay? And we can also switch that back to face shading if you want. Now if we click over here in our first window, let's make the gray value skull invisible. Same thing with the show trackball. And so these two little viewers, they work independently of each other, but again, because these are in the exact same location, we can say Windows, link viewers, and then the two move together. So this is really nice for, just doing a visual comparison, or if you want to take screenshots, then you can have your models in exactly the same orientation. Zoom it. So that's pretty cool. Okay, so this is a way to do just a visual comparison. I'm gonna go back to, I'm gonna unlink the views, and then I'm gonna say close current view. So we just have one window now with both skulls. So let's do some quantitative comparisons with these. Another thing you'll notice, it's kind of hard to see like where one mesh ends and the other one begins when you've got both of them the same color. So I'm going to make this first one a different color. Down here, make sure you have this solid cylinder selected, and then we can double click on this little gray box and just change a color. So this doesn't actually change the color of the mesh. If you were to export this with this color, it doesn't, you know, lock it into the mesh. It's just for while you're looking at stuff in the viewer. So we can kind of see that this blue mesh kind of sticks out in certain places where the gray mesh does not. So we should be able to capture that quantitatively as well. So that's going to be the next step. So we're going to go into the filters menu, and we're going to go down to sampling. Previous versions of Meshlab did not have a signed distance comparison, so you could use this Hausdorff distance, which has some really cool features to sample between meshes. But if you want to be able to get negative and positive numbers, not just positive numbers, then we're going to use the distance from reference mesh. And this little box opens up here. One cool thing about all of these filters in Meshlab is you can always click the help button, and it gives you a little bit more information about each of these. I know the text is insanely small, but so this says that we're going to compute the signed or unsigned distance. If you uncheck this, then you'll get an unsigned distance, but we want signed per vertex between a mesh point cloud and a reference mesh point cloud. Distance is stored in vertex quality. So the skull that we want to measure is going to be this top one. So the measurement values will be stored in that model. And we're going to measure for every vertex of that model, we're going to find the distance to the second mesh. And we want signed distance. This stuff, max distance, just gets filled in automatically. So we just leave it the way it is and click apply. And if you look down here, this little text box, again, it's so horribly tiny, but it says that it computed distance from reference. Here, I'm going to copy this so you can actually select this text. Select it and copy it. I'm just going to drop it into a notepad so it's easier to see. Okay, so it says that it sampled 175,286 vertices, which is how many our gray value skull has. And it found the closest points on the second skull. So we're getting a minimum of 2.725306 to a max. Okay. I don't know why the minimum and the maximum are the same here. That doesn't seem correct, but I'll show you some other ways to grab the stats. So we'll take a look at that. So first of all, let's make the second skull invisible. This first one, you'll notice it also has a little star next to it. That means you haven't saved it yet. So if you want to export it, at this point you can. But first I'm going to show you what you can do with that vertex quality value. So we're going to go up to filters, color creation and processing, and we're going to say colorize by vertex quality. And well, there you go. The minimum and maximum values are automatically dropped in here. And we're just going to hit apply. Okay, and these colors probably don't mean very much to you. So we can do something else. We can say render quality histogram, and it gives you this nice little histogram that shows you the scale of measurements or distance values with the colors. So red is negative values and blue is positive values. So the blue areas that are positive, it looks like that's kind of over 1.9, so it's sort of in the 2 millimeter distance range. So that means that this mesh in these areas that are blue exceed the other mesh by 2 millimeters. And so we can actually do a point check too. If you click this little I button, it says get info. So this lets you pick on a face, or if you click T and then click, it selects a vertex. And I know that's really hard to see, but it gives you the vertex index, the XYZ coordinates, and the quality, which says Q here in parentheses, and it also gives you the RGB alpha value. So might be a little easier to see the vertices here if I turn on like a wireframe view. And I'm going to go down here and select the wireframe and change the wireframe to, there we go, to a different color. So we can see the triangles are really small right here. So I'm going to zoom way in. Try that info key again. Hit a T. Okay, I've moved around. I've gone down here to where the there's some darker blue, and I can see that some of these quality values are over 2.7 here. Because it's so hard to see, and I don't think there's a way to increase the size of the mesh. If you look up here, the information it gives you, you can say click P to log the details. So when you type P, then the information for that point gets dropped down here into the little bottom dialog box. And then we can copy that and oops, paste it into here so we can see the quality is 2.72536. Click out of that get info button. Another thing we can do, I'm going to turn off this wireframe view up here, is filter select. And we're going to say select by vertex quality. So this is the function that's not working in 2022.02. So that's why I'm using this version. And so this kind of just drops some numbers in. So let's say we want to take a look at all the numbers over all the positive values. You can uncheck this inclusive selection and we can click preview. And now we can see all the vertices that have distances that are over 0, and we can adjust this over 1. Everything that's over 1 millimeter is pretty much, you know, all those little spots that we saw where the second mesh was kind of truncated, where the chin is cut off and all of that has these larger values. So you could select these areas if you wanted to. Once you have them selected, then you can actually say, you can right click on the skull here where you have parts selected, and you can say move selected faces to another layer if you wanted to. I would say not delete the original selection because we'd like to have that intact. And then, you know, you can have like a whole other mesh that just consists of those parts that exceed the optimal mesh. Pretty cool. And then you can just export that and save it if you want as a whole new mesh. And I'm actually going to export this original mesh that we measured. I'm going to say filters, selection, none for now. So that vertex quality value with the distance is actually accessible in a text file if you export this mesh as PLY and ASCII format instead of binary. So I'm going to say File, Export Mesh, and we want it to go in the same folder, PLY, and I'm going to call it like, you know, measured. Oops. Measured as a PLY. Save. And here you go. You have a color, vertex color, vertex quality. Let's go ahead and check the normal. Face color, yeah, doesn't matter. You can or you don't have to. And then the binary, let's uncheck binary and say OK. So now if we take that PLY that we exported, and I'm going to say edit with Notepad++, and here you can see all of it in text format. So this is a header that Meshlab puts on, and it tells you the order of the columns. So we have X, Y, Z coordinates, normal, X, Y, Z. Then we have the red, green, blue, and alpha colors. And then this very last number here is your vertex quality. So you can have that to, you know, do all your little stats with and stuff. There are also some other stats that you can generate in Meshlab once you have this vertex quality value, and it's all going to output down here. So let's go filters, quality measure and computations. And we're going to say per vertex quality stat. And it spits out down here at the bottom. I'm going to copy it, put it into my little notepad. See, here we have the correct min and max values. I don't know why the original, this up here was not correct. Weirdness. And then, you know, again, you can look at the text values. If you export the PLYs in ASCII format, then you can generate all these stats yourself as well. Min, max, average, median, standard deviation, and variance. We can also, under filters, quality measure computations, we can say per vertex quality histogram. So this gives you a couple of options. So it's going to show you, it's going to spit out, basically it's going to sort the data into 20 bins or however many bins you want, and spit it out here. So if you want to have a nice little summary or to make your own little histogram graph instead of what Meshlab puts out. And again, we can copy all of this. You know, it would be really quick to just sort of, actually, did it copy? Did not copy. The easiest thing to do would be to generate a bunch of these functions really quickly all in a row and then just copy all of the entire area there. But so you can see this goes from the full range from negative 1.47, and it tells you how many vertices have that value. And so we can go further along. We can see the highest values are negative, I think the highest values, yep. Well, for some reason that filter is giving me two sets of numbers here that are doubled, and that doesn't make any sense. So I'm going to open this in the latest stable 2022.02 and show you that, because that looks more accurate. Okay, we're back. So I just took that PLY that I exported. It was in ASCII format, but I just dropped that into 2022.02 so we can look at these stat functions properly. Okay, so let's say per vertex quality histogram. Okay, we have our negative, positive numbers automatically dropped in here. 20 bins is fine, apply. And you can see that the data dropped down here and it looks better. There's only one set of bins. So I'm also going to click this area weighted and apply that, and then just export both sets of the data here. So now we have a set of bins showing the number of vertices for each value range. And we can see we have the highest number of vertices here in the negative values up to negative 0.63. And then the second set is showing us the area of the mesh that has these values. So what are we at? The highest is here. I mean, it should, roughly line up with the number of vertices. So render vertex quality histogram. There we go. So there you have it. There's just really quickly, if you were to do this type of comparison, there are some other geometric numbers that you can get for each mesh. So if we go under quality measure and computations, then you could say compute geometric measures. And again, this spits out down here. And we can copy that. So this gives you the bounding box size, the diagonal, the surface area of the mesh, and a lot of other information, surface area, volume, center of mass, all kinds of stuff. And let's see, there's one other filter, compute topological measures. And oh, I'm having such a hard time getting these numbers copied. So this is telling you the number of vertices, edges, faces, unreferenced vertices, which we don't have any. It's just a one mesh. So there are other ways of comparing meshes too, but that one's kind of the main one. You could even compute very quickly, compare, do this in reverse. So let's go with the STLs. So you could measure from the second mesh to the first one. So we can do that in reverse and colorize that. Filter, colorize by vertex quality. And then render histogram. I mean, and you could look at, like at both of them at the same time, and you can see that one is, the optimal mesh is sort of on the positive side, although the negative areas tend to be kind of high, going up to 2.2 millimeters. And the gray value skull tends to be, it gets confusing, more negative than the other mesh. So, and then you can just export it and you can have all of this, geometric data and all of the distance data, and maybe get some more valuable outputs than you would through other software that maybe doesn't give you this information per vertex. Yeah, so try it out and let me know what you think.